Libsyn version 2 was like a thing I worked on.
It's like version 4 now.
Yeah, something like that. Yeah.
Wow. So what was it like working there? Was it good?
It was really cool, and I really liked the people. It was interesting because I had started working there, so they got acquired by a big media company, but the big company mostly left them alone. So it was like working for a startup, but like there was none of the normal pressures of like a startup where you're trying to get users and stuff, because they already were really big and had a ton of users. So it was kind of like a really interesting thing, and like some of the people that I work with there, I'm like still friends with today and stuff, and so it's cool.
Yeah, we use it for our hosting as well. Yeah. The only thing that feels a little bit awkward is that the interface looks kind of old and crufty.
Yeah, it's because the guy who worked there that worked on the interface left a long time ago, and so now I don't know who they're like.
So if you're looking for UI work,
apparently
we're not sponsored, but we should be. And I'll probably add some kind of introduction too, unless you want to introduce yourself.
Yeah, I don't know. I always start with like, "Hi, I'm Steve." I got a little tick on that in my presentation, so I usually do that. So I'm currently working at Mozilla, paid to write documentation for Rust. And part of the reason why I love working for Mozilla is that my personal interests and goals align a lot with Mozilla's. But we should definitely say that like this is my opinions, not Mozilla's opinions, because I'm going to be talking a lot about Mozilla technologies. But that's like doesn't mean that Mozilla believes these things. It's like my own thing. So I used to I've worked in open source for most of my career. I used to teach Ruby on Rails as a job, and then I worked on Rails as a job, and then kind of got into the Rust stuff and have mostly been doing that professionally. But I've been really lucky to do open source most of my career, basically, which is really interesting.
Was it a conscious choice somewhere in the beginning? Or
it's a thing that I always was interested in. Like in college, I sort of discovered Unix and like dug deep into like the Unix culture, and so that kind of became a thing. I grew up with Macs, so I was a really big Apple fanboy, but I couldn't afford new ones. So when it came time to buy a computer, it was like, what do I do with it? And I had been following the move from Mac OS 9 to Mac OS 10, and so I knew Unix was becoming a big thing in the Apple world, and so I decided to just go straight to Linux, and so I got pretty heavily involved in the sort of free and open source ideologies and working on all that stuff. I like the fact that it's about building a commons. Like I'm very interested in people over companies, and so that whole attitude like works really well, and so it was definitely a conscious choice. I think I could have made a lot more money in my life had I chose to work on not open source software, but I feel much better about what I'm doing.
I could be rich by being miserable. So.
Yeah, totally.
So how long have you been at Mozilla?
It's something like 3-ish years now. It's been somewhere around there. It's sort of hard. I used to do a lot of conferences. This is my third or fourth Øredev, and it was always a special conference to me before I even managed to attend. So I've traveled a lot, and that makes timelines get a little hazy. So sometimes it's harder.
I know what it's like.
How long things are.
But roughly a couple of years.
Somewhere around 3-ish years.
Yeah, I've got to ask now that you mentioned. So, what Øredev? I mean, it's pretty big in Scandinavia, but so where does it travel a bit farther?
So specifically, John Moore gave a talk in 2010 on hypermedia, and that was a concept that I was interested in but didn't really fully understand. And watching his presentation was what finally made it click for me. And I went, oh, this is a thing I want to do. And so I became a pretty big advocate of the hypermedia stuff. And still somewhat to this day, although it's not really as big a part of my life as it was then, that kind of sort of set a major professional and personal interest for me for like a couple of years. And so I was like, I've never heard of this conference, but this talk is amazing. And John is a great guy. And so like, I always wanted to come and finally actually made it. It's extra funny since, your audience is mostly in Sweden. The train from Copenhagen to Malmö was the first European train I ever rode. And it's funny because I tweeted something about like, I'm really nervous. I have to figure out this train situation. And if you've ever taken that train, you know how trivial and easy it is. But, you know, in my mind, it's like I'm landing in a different country.
Yeah,
I have to take the train to the other country.
Yeah, there's no limit to how difficult this could be.
And so it seemed extremely hard. And all these people were like, why are you worried? It's not going to be a big deal. And then they're like, aren't trains a thing in the United States? And I was like, no, not really. Like, they exist, but they don't work very well. And I've never used them. And so now it's like, you know, it's funny to look back on you know, that part of my life and be like, oh, yeah, there's definitely no reason I should have worried.
Yeah.
So that's kind of also funny. It's a meaningful part about this conference to like me personally.
Yeah, that's a connection.
Yeah.
And I like that you put up the image of the no balloons sign. I noticed that the other day, and a friend who, he doesn't work with the conference, but at the same company, and he said, there's always at least one speaker who mentions it every year.
Every time I come, it makes me smile, because I understand why it's serious, but it seems like such a trivial thing to have a sign about that it's like kind of amusing.
Yeah. So you're working on Rust the documentation side of Rust.
Yes.
Yeah.
I got a computer science bachelor's degree, but then I almost got an English graduate degree. And I've always been interested in writing. I've spent far too many hours of my life arguing on the internet with people, and so that's usually over text. And so I've been like typing at least something, you know, in the written form for basically my entire life, like from high school on. And so this also sort of comes into my like teaching thing. So I've really enjoyed teaching a lot, but at some point I sort of realized if I teach one class a week and it's 30 new people and I introduce them to how to program, that means that I have a maximum output of 30 people a week. Yeah. And if you've ever done that kind of work, you know that you're never at full capacity anyway. So maybe let's say like 2 weeks a month at best. Yeah. Whereas if I write things and people read them, you know, thousands of people can read what I've written in a short period of time. And so to me, writing is a more scalable form of teaching. Yeah. And so that's kind of what got me interested in doing it. And finally, it's sort of a kind of like an empathetic thing. Like I love using software when it has great documentation, and I always like curse when I have to use software that has terrible documentation. And so the fact that I enjoy writing means that I am sort of a more rare programmer personality. And so I've never found it difficult to be involved in projects, because if you want to write documentation, you are welcomed with open arms. And so, you know, that's kind of a fun thing. When I got the job at Mozilla, actually, I was on contract at first because they didn't really have any job openings at the time, but they were like, we will find some money somewhere to pay you. Like, if you want to do this, please. And so, you know, there's that kind of side of it as well. And that's been a great way to get, you know, involved in open source work. And I think that, you know, for a certain kind of person, if you've never worked in open source before, it's a fantastic way to get started, because people want to help you improve their project. And it also means that you can learn a lot. So I wanted to do this with Rust partially because I was like, the people who make it have to explain it to me in a way that I understand, because I'm going to be the one explaining it to other people. So I get like personal tutors from the people, you know, that do the hard work, you know, on the project. And so, you know, I think both of those things are kind of like a, you know, a great way to get involved in open source work, is to work on documentation. So.
I mean, I'm trending a little bit in your direction when it comes to like liking to write and writing a lot. And so I definitely share your impression that, I mean, it's easy to, if you come in and say, I would like to document this, for example, like, yes. And then you write something, you feel good about it, and then you wonder, why didn't anyone else do this? It was so much fun.
And even just writing examples, like the way that I learned Rust was, okay, I should write examples for every function in the standard library. So I have read the entire standard library, and so I know it well because, you know, I had to do that. And so that kind of, I like the fact that it plays into all these different kinds of things. And so that's, nowadays, that's usually where I find myself, is in the sort of like documentation sort of work.
Yeah. So how do you work with the documentation as the language is evolving? Do you like wait until a sort of final version, or do you write like this might change?
This is always a problem. So before Rust hit 1.0, so Rust 1.0 was in May of 2015. And so as things got closer to that date, things got more and more stable, and so it was easier and easier to write words that weren't going out of date. However, the new problem comes in when you know, we care about backwards compatibility a lot in Rust, and so you know, years later, we're still at version 1.x. You know, we care a lot about that. but new additions can sometimes change things like idioms. And so we're currently as a project trying to figure out in general, how do we handle this problem? And so we recently have decided to do this thing that we're calling epics or epochs. It's funny because the word, nobody knows how to pronounce it.
Yeah.
It's a UK versus American thing. And so, but basically every 2 or 3 years, even though we're not going to be doing breaking changes, we're kind of going to do a sort of like celebration, large release being like, you know, if you've never looked at Rust before, the language has changed significantly. Now you should come look at it again, or like, you know, sort of a way to communicate. Like when you don't have a 2.0, you don't get the marketing benefits of a 2.0, and you also don't have the problems of upgrading code to 2.0.
Yeah, true.
And so we're going to kind of do this sort of like, you know, conceptual new Rust release. And so that's sort of when we integrate new features from the docs. I sort of have like a running list of like, here are the things that are added that I have not put in yet. And that stuff it'll kind of come together, you know, at these new major releases. So, so most of my biggest work is writing the book, the Rust programming language is like the book on Rust. And so we're kind of going to have additions that correspond with each of those. So, you know, every time a new one comes out, there will be a new edition that has incorporated all the things that have happened over. It's probably going to be every 2 or 3 years is what we're guessing at the moment.
So this hasn't started just yet.
Yeah, not quite. Well, so this is the first one is the hardest, right?
Yeah,
so
of
Rust 2015, like, is sort of, if we backfill that idea, it's now the end of 2017, and so it's likely that probably 2018 or 2019 will be sort of the first announcement of these kinds of things. And so how that exactly is going to work with the book is still... I actually, right before this podcast, was writing the first drafts of the appendices. So, you know, like, even though you can read the draft online, we're publishing it with no starch, and they're going to pour a printed version. So, so I'm kind of wrapping up the final editing of this first. It's like the second edition, but it's like actually a rewrite of the thing that I wrote for 1.0. So there's kind of an off by one error there, where it's like sort of in print it will not be the second edition, it will be the only edition, but it's kind of conceptually the second edition of the book.
The new edition.
Yeah, so that's wrapping up, but then in a year or two, we're probably going to have to do this first, you know, like it's not going to be the same kind of massive change, but a significant revision to add in the new features that we've been, because we have some new stuff coming down the pipeline that's going to be very nice for Rust developers. And so it's big changes in the sense of your old code will still compile, but your new code will be much simpler and nicer to reason about, and like those kinds of things.
Good stuff.
Yeah.
So what is happening in Rust right now, or what has happened since?
Yeah. At this moment, specifically, one of the other things, so I guess I should back up slightly. We release a new version of Rust every 6 weeks. Which is very aggressive for a programming language. And we follow the same release model as Chrome and Firefox do, basically. So we have a nightly edition that comes out every night, and then every 6 weeks a beta branches off, and then every 6 weeks that beta turns into stable, and the old nightly becomes the new beta, and kind of does that like train model. And so, you know, so there's new continuous improvements coming out every sort of 6 weeks. But as part of that, it also means that, you know, we have this RFC process by which people propose new features to the language, and, you know, we work on the proposals and then we accept them or reject them. And that's sort of the first step of getting a new feature in. Yep. So the problem is that some features are bigger than others and some features are more important than others. So we've kind of developed a backlog of features that we have accepted conceptually, but not actually implemented yet. And so we decided that this is the first year we're doing this, but we're hoping every year, sort of September to December, will be no new proposals accepted, only working on implementing the backlog of things we've already accepted. Yeah. So we're calling it the impl period because impl is a keyword in Rust, and it's how you write methods.
Yeah, makes sense.
So we're kind of halfway through that, a little bit towards the end, I guess, right now. And so it's sort of a nice way to finish out the year by shipping all the stuff we've been talking about, you know, early on. So there's been a lot of new stuff that has kind of been happening lately that's like very exciting. It's sort of a little hard to describe without the actual text in front of you, but a lot of it is focused on ergonomics. So in Rust, we sort of care about safety, performance, and ergonomics, but in that order. So we want Rust to be as safe as possible, and then after we deal with that, like we want to be as fast as possible. And only after those two constraints are satisfied do we worry about making it, easy to use, because there's certain things about the low level and speed stuff that means you just naturally are a little more verbose than some other languages. Yeah. But that also doesn't mean that it has to be that way.
No.
So we've come to learn like there are certain things that we did that we could actually make them easier to use. And so we've been working on several features that are kind of related to, improving the ergonomics of programming in Rust. And so I'm really excited about a lot of those. Yeah. And some of them are very simple and some of them are very complicated internally, but at the end, what it means is that your Rust code will be simpler and easier to understand as a programmer.
It might look different to people.
Yeah.
In a positive, simplified way.
One great example of this that's, I guess, relatively easy to talk about is error handling. So we basically give you the way to return from a function, like if this is an error or a successful value.
Yeah.
And so a lot of times, if you get an error, you don't want to handle it yourself. You just kind of want to throw it up the stack like you would do with an exception. Yeah. So we originally had no great way of doing that. So you'd have to check every single line like that could fail. Like, is this successful or is this an error? And you would like return that error up. Mm-hmm. And that was not great. So we added a macro to the language called try. And try would basically take one of these results and say, okay, if it's successful, return the successful value. And if it's an error, return the error to the caller. But even the macro was a little more verbose than we needed to be. So we recently added a language feature, which is question mark. And you just toss a question mark onto the end of an expression and it will do the same thing. And so this kind of gives you this progression of like the most verbose, but clearly handling it, and then a slightly better solution, and then this final like nice, kind of thing. So we've been applying that attitude to several other parts of the language with like, can we take patterns that are a little more verbose and add shortcuts in a way that doesn't obscure what you're trying to do, but makes it a little easier. So, Rust code from a long time ago will not have these niceties, and you'll see all this stuff. Yeah. And then in today's Rust, it's like a little more concise, but you still know that that's what's going on.
Yeah. But the old way of doing it is still
it's still compiled. Yeah, absolutely. Like we didn't get rid of it. We just said this is deprecated and kind of don't explain, like in the book, we used to explain these things, and now we just say use question mark. And so you won't know that try exists until, if you see it in some code, you can still look it up in the docs and it'll say this is a deprecated way that you should use question mark now. But if you see code having this, here's how this worked, and we do that kind of thing.
Is there an organized plan for like removing deprecated stuff eventually?
So this is part of the epics thing. So in one funny thing about programming languages is that like backwards compatibility is actually like not a real thing. Like the problem is, especially when you have a static type system, any change can technically break someone's thing. So a good example of this is you have the ability to say like use every function in this module, and instead of naming all of them, you can put an asterisk and it'll import everything. But that means if I have a foo function defined in my code and I'm saying use standard IO star, and then we add a foo function to standard IO, now there's a name conflict and my code doesn't work. So even adding a new function can cause this sort of small incompatibility. So what we care about is more of a like social compatibility, in that like it should not feel difficult to upgrade your code. So we generally like work really, really hard to make it so that you can always upgrade to a new version of Rust and not have it be a stressful event. And lots of our users upgrade every 6 weeks, and most of 99.99% of the time when they do so, their code just works and it's great. Like, and every once in a while there's a little thing where it's like, okay, so in that situation, you can disambiguate it by changing some stuff. And so they're like, you may need a small amount of change to upgrade that, but it's just not possible. And so we really looked to languages like C++ and Java that are known for being very backwards compatible, and we wanted to model our improvements model after them. So people think of Java and C++ as being never breaking backwards compatibility,
it just works.
But actually they both break. Every single release they break some stuff. They just put in the work to make sure that it's not a big deal for people. And so the way that this works in both languages is they basically have a flag that says I want to use this version to compile my code. So with the C compiler or C++ compilers, you can say like -- standard equals and then the year of the standard you want to compile. And with Java, there's like a version flag to get exact compatibility with that previous version. So we're going to do something similar where you can sort of pass a flag to say what version you want to compile on. And so when we have one of these new epics, we'll be able to remove some things that were deprecated. And as part of that, again, we care a lot about it being not difficult. So one of the things that we're going to do is sort of always assume that you're on 2015 Rust, doing little air quotes, unless you've specifically passed this flag. So what that means is that once you upgrade to the version of the compiler that has support for sort of 2019 Rust, when you generate a new project, it will automatically stick a configuration in the config file that says we're using 2019 Rust. Yeah. But that means that all the previous ones will work with 2015 Rust, and you can totally mix and match those within your project. So all the old packages will still build and still totally work, even if you're writing Rust 2019, you use a package for Rust 2015, and it just works with no problems. Yeah. So that's kind of our plan for eventually deprecating some things. As part of that, there's sort of some technical details around we can only make relatively superficial changes in this way. So one example is like adding keywords. If we add a keyword, if you had a variable named that, now that would break. Mm-hmm. So we're going to have a thing that will say, hey, in the next version of Rust, this is going to become a keyword. You may want to consider changing it and or explicitly stating that, you're going to be on this, older version. And so if we change the language too radically, like one of the reasons why this works in Java and C++ is that while they're technically breaking changes, the basic concepts of the language are mostly the same at the core. Yeah. And so it's sort of similar where we won't be doing like a Ruby 1.8 to Ruby 1.9 or a Python 2 to Python 3 kind of like massive breaking changes ever. Like, and so because it's also a maintenance burden, if you want to support every previous version, if they're totally different, you effectively have two totally different compilers. So we're basically only allowed to change the front end part of the compiler, not the like big middle, meaty bits. And that's not only for our maintenance of the language, but also as a Rust programmer, you shouldn't need to be able to switch between two totally different models of how the language works, for a new release. So the core of the language is always going to be the same kind of thing.
Right. It's nice and settled in that.
Yeah. Because, you can't build, like, people don't build bridges on sand, right? Like, you can't build a tall building with a bad foundation, and so you need stability to be able to, like, build big systems. And so it's something we care a lot and put a lot of work into. We actually built infrastructure, so our package manager ecosystem for, download open source packages and use them is called Crates.io, because Cargo is the package manager, so Cargo takes your Rust and puts it in a crate and ships it to other people. As a little metaphor there. We actually have infrastructure so that we can say, please take the newest version of the compiler and try to compile and run the tests of every open source package that exists and see if it breaks. And so we can actually know we can actually know, like we can tell you, and so this has happened before where, maybe we have a change that we're pretty sure is not breaking, but we're not 100% sure. We run it on the ecosystem and we find out that 5 packages would break, and we send them pull requests and say, here, this is going to become an error, so like get it fixed. Yeah, and so what that means is by the time it goes through the trains and hits the new stable release, you won't notice these things like generally breaking. And so that's really, really important to us as keeping this stability because, people expect that these days. So we put in a lot of work, but it's definitely really rewarding.
I would say so. I mean, it was a special case, but I got access to some Swift code and a Mac app, and it was written in Swift 2. And I got access to it like a year later, and Swift 4 was the current one. And to start with, to download the previous version of Xcode to even be able to open it. And then I could try to compile it, and I had to fix errors. And I mean, I don't think they aim to do that over time, but it's a good example of when you don't do this kind of work, how difficult it becomes.
Yeah, the Swift people have done a good job of setting expectations in that regard. So they've said explicitly, like, we're going to be breaking in the future. If that's not for you, stick with Objective-C. Yeah. And so the newer versions of Swift now have a source compatibility. So they're like, you'll be able to compile those two things. Yeah. And then I think Swift 5 is going to be ABI compatibility. So it will always just work. But it definitely has been a pain early on. And we had this with Rust before 1.0 because we were changing the language on sometimes a daily basis. And so you would go day to day with your Kappa code entirely breaking. So, that's kind of, it was fun in a sense, but no one used Rust in those days because who's going to write software when you have to,
exactly.
It was my job to work on it, and sometimes I still wouldn't understand what the changes were that had been made. So, so it's very different nowadays.
Yeah. So, do you do coding on Rust development as well?
So I don't really work on the compiler, but I do a lot of auxiliary work. So for example, I'm currently in the process of working on the next generation of the tooling that we generate our documentation with. So I do I code on that stuff. I maintain the semver package that Crate Cargo uses to determine what versions match with stuff. And I have a project with my partner Ashley where we are writing an operating system in Rust and then also writing a tutorial. As we build the OS, we write the tutorial on how to do it so that you can get into operating system development while working on Rust. Wow. So I kind of have these projects that are off to the side as well as, actually doing the work. But technically for my job, it's all English, not code, most of the time.
Which is more difficult. It's much more ambiguous.
There's no compiler to make sure that it's understandable.
No warnings. You just get angry complaints. So you're building an operating system in Rust.
Yeah, it's fun.
I imagine.
Most of my friends in college were operating system developers. And so once I found Perl and Ruby, I kind of went, cool, I never need to worry about that ever again, and went into the web. But learning about the low-level stuff is lots of fun, and so it's explicitly not something we intend to be I am under no illusions that production usage of my OS will happen someday, but it's because I think that unless you go to college, it's really difficult to get into operating system development because there's not a lot of resources out there.
Yeah, that's what I was thinking too.
The pitch is kind of do you know JavaScript? We can teach you how to build operating systems. And so we're currently, to give you an idea of how far along this is, the book goes from writing some assembly code to boot up the computer to hello world sort of main. But the actual contents of the kernel has keyboard input and output working, but we still haven't written the tutorial for that yet. So that's kind of the next step, is writing some tutorial and then add some more features and write more tutorial and add some more features. So
it sounds like a project for me. I mean, JavaScript developer, not knowing much about operating systems.
It's like a long term, I think that it's going to take me 10 years before I have something that is like a replacement for an operating systems class, because it's like my side project, so I haven't been able to really work on it for the last 4 months, and that's okay sometimes with side projects.
Sure.
But I'm sort of taking the long view explicitly and not getting stressed out that I haven't worked on this in a couple months, and that's totally fine. There's plenty of time for that to be.
It's so hard to not get that feeling sometimes. I mean, I do it all the time. This is a side project. It's meant to be fun. I work on it when I have the time and energy.
Definitely.
I don't have to work on it. Wow.
There's a more serious project called Redux that actually is they have a full GUI and networking support and all that stuff that exists if you're interested in something more production ready. But we're going the pure hobbyist explanation kind of route.
It's good learning. I mean, it's one thing to boot up something and see what it looks like. It's wow. But actually learning about the steps is a whole different thing.
Yeah, definitely.
So what other larger code bases are there out there in Rust?
So some of the largest are the Rust compiler itself is built on LLVM, but that's in C++. It's 2 million lines of C++. But the compiler is something like 650,000 lines of Rust code, I think, at the moment. Servo, which is the web browser that Mozilla is writing entirely in Rust, is something like 950,000 lines of Rust at the moment. So it's pretty solid. And there are some closed source code bases that I have not seen, but I've heard are roughly in the same ballpark. So we kind of have somewhere in the area of 8 to 10 brushing up on 1 million lines of code. Code bases are kind of the largest ones. And there's lots of more ones in the sort of 50,000 to 400,000 kind of range. Because same thing, right? 1.0 happened 2 years ago. It takes a certain physical amount of time to type out a million lines of code.
Yep.
So we've only had 2 years, so that's kind of like
pretty good result for 2 years.
It's not too bad.
Yeah.
Well, both the compiler and Servo had the advantage of being before then, so they've been in development. The compiler's been under development for like 8 years now in total, and Servo is something like 6 or 7 years old. So and it actually, the compiler was totally rewritten at one point because it's in Rust now, but it was in OCaml originally. So there was also kind of that sort of thing in the history. And so, so it takes time, but we'll get there, and we're seeing more bigger code bases. And due to Rust's strong guarantees, that's actually what a lot of people sort of believe, that you don't really get the benefits of Rust until you have a larger code base, because it helps you really you make a small change and then it's like, here and here and here and here and here and here and here are all the problems you've now introduced. And that's like much nicer to do in a language that's very strong, cares about these things, than something more loose. Like when I think about the giant Rails applications I worked on before, and you change a line and you're like, okay, I hope I have tests. Right?
Something happens.
I still love Ruby and will always love Ruby. I have a tattoo of a Ruby on my body, actually.
Nice one.
So that's not saying that Ruby is a bad technology, but in terms of working with large code bases, like static types help so much in my experience.
Different tools for different purposes.
Yeah, absolutely.
Speaking of Ruby, when I was doing my research, I discovered I discovered Closure, the whole thing.
Yeah.
The book, I guess we should call
Sort of, kind of, I guess.
Which was written by Y, the Lucky Stiff?
Yes.
And sort of taken care of by you? Or what's the story roughly?
So
like?
To back up slightly, because it's actually one of those things that more and more people don't know about anymore. There was this programmer in the Ruby world named Y, the Lucky Stiff, and WHY, which leads, it's funny to talk about because it's very hard to parse. I was in a cab talking with someone else about why, and the cab driver was like, I'm sorry, I'm not trying to listen in on your conversation, but like, what are you saying? It's like very who's on first.
Exactly. It doesn't even parse.
So Y was this persona of this programmer in the Ruby world, and he wrote a lot of really wonderful Ruby software and a lot of great tutorials. He had this thing called the Poignant Guide to Ruby that was a lot of people, including mine's introduction to Ruby. So I really admired his work. And then in August of 2009, he decided to delete all of his stuff off the internet. And so I thought that his project, Hackety Hack, was like a very important software project, and I didn't want it to die. So I decided to keep working on it after he disappeared. And that's actually how I got started in open source, like proper, was taking over this project. And then, I was like, I'll help open source, there's communities and people work on things, and so I'll help out with that. But then I was the only one who showed up, really. There was like me and 2 other people who they had other things to do and sort of dropped off. And so I was kind of here alone now in charge of a project. I thought I was going to be assisting someone who knew what they were doing with. And now I'm in charge and I get to make the decisions. And so I was like, oh no, like what have I done? And there's a related project called Shoes that is the sort of GUI toolkit that he used to make Hackety Hack. And that project is actually still going to this day. They're about to release a version 5 pretty soon. And so it's a nice way to like write GUI applications in Ruby. I worked on Hackety Hack for a long time, and eventually I stopped working on it for a number of different reasons. But one of the things that was really interesting and complicated about that experience is like you're picking up someone else's life's work and making it your own life's work. And I struggled a lot with trying to figure out what would he have wanted for this project versus what do I want with this project. And like, that's like a very complicated sort of thing.
Oh, yes.
So eventually he came back and did this really interesting thing where he basically, his website reappeared briefly and it said like, at this time on this date, some stuff is going to happen. So check it out. And what it was an RSS feed of these binary files were getting posted. And if you inspected the binary file, it was like the binary file that you would send to a printer to print out something. So basically, people wrote these scripts to watch the website, and when a new one was posted, they would grab the bits and then send them to a printer, and then you would just get to watch the pages come out of your printer.
Wow.
And so I did this. I happened to have access to a printer at the time, which is really lucky. And, and so every half an hour, my printer would start up and I'd be like, oh my God, and run over and read the next page. And you would get to the end of the page and then you just have to wait for the next. And then sometimes they would take 45 minutes instead of half an hour, and you'd be like, oh no, is it like over? What's going on? And so it became this document, and he didn't title it. Mm-hmm. And for me, because I have this like close relationship with his work, but never him, I never met this person. For me, it was sort of a lot of people were worried that he had like died or something, or like something had physically wrong had happened to him. And it was pretty clear from reading the document that like he was totally fine. And he just needed to move on with his life, and like there's a bunch of other reasons. And so for me, it was there was specifically one throwaway line in one part of the book that was like, I think that the work that other people have done with my stuff is good. Yeah. And I was like, okay, that's like what I've been waiting to hear for like years. Because, a lot of people were like, sort of had accused me of like riding on his fame and like, that kind of stuff. And so that was also part of why I felt really conflicted about doing this. Yeah. And so for me, it brought a great deal of closure. Yeah. And since it was sort of the end of his story, I thought that was appropriate. And closures are a big feature of Ruby, which is like the other kind of closure. In so many ways. Yeah, so I drew up a cover and took a photo of it and decided that I would, because I was like, we need a way to talk about this work. Yeah, and so I gave it the title Closure. And so Closure is my title, not his title. Yeah. But I think that's like kind of appropriate. And so I gave a conference talk at Madison Ruby later that year, sort of explaining what was in it, because it is very much like all of his work, like a work of art, and it's very dense and sort of hard to understand. Mm-hmm. But it turns out that I like to read some of the same authors that he likes to read, and so I like picked up on a lot of the themes Again, I was going to go for English school, right? So I have this awareness, and so a lot of people were like, none of this makes any sense to me, Steve. So could you like give a conference talk on like what you saw in his writing? Yeah. And so if anybody's interested in learning more about that, you can like look up that video of Madison Ruby. And sort of like I sort of gave my my sort of thoughts on it. And so I still have that physical paper. I actually just recently moved, and like I still keep it with me because it's one of my favorite possessions.
You wrote a blog post about it as well. Yeah, because I'm pretty sure I read yours and at least one more person's, and it's super interesting to see what people see in it, because I didn't have time to read the whole text.
Right.
So, but I scanned it a bit and like read parts, and then I read your thoughts around it and it's other persons, maybe someone, and it's so fascinating.
Yeah, I definitely think that's one thing that makes good art, is when it makes you think and it makes different people think different things, and you have to sort out what it actually is like. So I think it's definitely an accomplishment for sure.
Yeah. Are there more people like that out there who write in the same, or not the same vein, but similarly?
There's definitely lots of stuff in varying degrees. So there's actually, it was very popular a couple years ago and it sort of died out slightly, but there's this thing called the digital humanities, which is people in English departments who are interested in technology, and they apply humanities techniques to technology to sort of like figure out them. And so they're like anthropologists who study programming in an anthropology sense. And there are actually people who there's the person I really enjoy, Kevin Brock Latour. I always forget which one of his last name or middle name is, but he is a person who studies rhetoric. And he's like, what is the rhetoric of source code? Like if we treat source code as the written word, like it is a language, then like a lot of the arguments programmers have about style or naming, like people go over and talk about English or Swedish or whatever, what makes for good style or naming. And so you can take those same techniques and apply them to code, which is like very interesting. So there's a lot of that kind of similar-ish work in varying degrees. Some of it not as creative as the work I was doing, but sort of similar, like blending these kinds of things together in various ways. But I definitely don't think I always think of Y as an artist whose medium was code and words. And a lot of these people are more like researchers, which is an equally cool thing, but in a very different way.
I was also thinking about that. Code as art aspect.
A lot of the art people now are working in like virtual reality and or like physical, like we're gonna have someone at Øredev who has the gloves to make music and that kind of stuff. So there's a lot of interesting things going on in a lot of places.
It just feels like there should be so much more of code art in one way or another out there, because we are so many people writing code and writing words, and we should be able to be equally creative in it's just different forms of writing.
Yeah, I think one thing I love about cross-disciplinary work is that, you sort of get to learn about other things, but one of the big problems with cross-disciplinary work is that it means that there's only so many hours in the day. And so you will never be as deep as somebody who only focuses on one thing. So I have done some work in sort of a related area, and there will be people, like when I talk about the philosophy of programming, programmers are like, that philosophy stuff is stupid and you made one technical problem in your code, so this is invalid. And philosophy people will be like, you missed an important insight from that philosophy book, and I don't know the programming, so you kind of get attacked from both sides. And so I think that like there aren't more of those kinds of people, because you have to be willing to subject yourself to criticism by experts in two areas instead of just one area, and that makes it really, really difficult. I do a lot less of this kind of work than I used to for those sort of reasons, because it's very challenging to put yourself out there like that.
Did Y get lots of feedback like that as well?
It's definitely. So within Ruby, he was beloved by virtually everyone.
Yeah, because that's the only image I have.
Yeah, a lot of people outside of Ruby used it as a way of saying like, oh, look at those Ruby people, they have no idea what they're doing because of this, kind of thing and stuff like that. And there are also some people who saw it as a little bit of a like cult of personality, and the idea, like we do a lot of revering experts in programming world, and so a lot of people who are wary of revering experts were like, the amount of people who love this person for reasons is like in itself a problem. Like, we can't keep doing this like cult of personality thing around programmers, and so there was also some criticism from that angle too. There's somebody who's mad at everything, even stuff that's wonderful, right? Like you could be just purely posting pictures of puppies onto Twitter, and someone
you should be doing something better.
This is a bad photo or whatever. It's like, come on. So
it's not properly compressed.
Yeah, right. So that kind of thing's always going to be there.
So true. I've taken up a bunch of your time, but it's super interesting. Is there anything else you want to go into?
Well, we're talking about Webassembly a little bit.
Oh, yes.
So if we have time, I would love to talk about Webassembly.
I have time.
So I've been really excited about Webassembly, and I think that I should start this off by saying I think a lot of people know that Webassembly exists, but they don't understand what it is, and I don't think that's their fault. I think that's like Webassembly's fault. And part of that is because it's just like WebAssembly is accomplishing a goal that we have been trying to do for a very long time on the web, but it's doing it in a very different way. And some of those subtleties are lost to people that don't pay a whole lot of attention. And some of it is because the people that are doing this work aren't necessarily thinking about the like marketing aspects of it. And so when I sort of like dug into it and I realized what it is, I was like, this is amazing. And the final reason is because it's still a little early. So fundamentally, WebAssembly is not even about the web, actually. It's funny. Technically, WebAssembly is just a specification of an assembly language. So that's interesting, first of all. And it's like, why does this matter? Well, we've always had this privileged position with JavaScript on the web because browsers have always shipped to this, not always, but for a very long time. It's funny the Mozilla person being like always, but like, for a long time there has been JavaScript on the web, and people have tried to do alternate things. There was, Java applets, and more recently things like PCNackle and Dart and like these other attempts at getting things. And they all sort of failed. And the reason why they failed is that many of them were tied to a single vendor too much. So, Java being a Sun thing at the time, and PCNackle being a Google thing. A lot of people who were interested in the open web were like, we don't want to wholesale adopt a technology from a particular vendor. A second problem with them is that they were so different than JavaScript, it would require shipping an entire separate runtime environment, and now you have two of them. What are we going to have 5 of them later? Like, how does that work?
Maintain that.
And then the final reason that was true, especially for Java applets and also something like Flash, is that they were effectively totally separate from the web as a platform. So you got a block on the screen, and as far as the browser was concerned, that was just a black hole, and everything else happened sort of inside this. And that was a really big problem for accessibility, and it was a really big problem for like a number of other reasons. Like it just wasn't well integrated into the web platform. So WebAssembly came from this project called Asm.js, which is a move by Mozilla. So Google announced this PCNackle, which was basically like run LLVM code. Like you'll ship LLVM code to the browser, and then it will run it in this sandboxed environment. Mozilla had some problems with this, and they said, we can actually fix this by retrofitting this onto JavaScript, and came up with this thing called Asm.js, which is basically a way to add type annotations to JavaScript. And it was never intended to be a thing that you would write. It was a thing that you would compile into. And then the idea is that they would recognize this special string that said use asm, and then they would compile it. And like one of the biggest things it gave you was just integers. like having integers is like really good and like important for fast code, right?
It's useful.
But the important thing about asm was that because it was just valid JavaScript, the only thing Asm did was make stuff faster. So you could take anything that was built in Asm and run it in any browser that ran JavaScript. You didn't need a separate virtual machine. You didn't need any special things. And there's some other reasons, like LLVM IR is great, but it's not cross-platform compatible, and that was a problem with PCNackle. And the fact that you would need to do this like compile step was like complicated. And so Asm sort of proved out like we can actually have a faster way of running applications on the web without needing to abandon the JavaScript virtual machine and like JavaScript in general. And so then that turned into WebAssembly, which basically is an assembly language, but what's most important about it is its semantics are really easy to add to an existing JavaScript virtual machine. And so it's a way of having this like kind of work out. But it's not specifically tied to JavaScript virtual machines. I've actually been spending the last couple of weeks just handwriting my own parser and VM implementation for WASM, and like it's totally feasible to do as an individual. The specification's like 160 pages long, and it's like not that that's always a good measure of complexity, mind you, but like it's very, very simple, and it's also then they're broader than the web. So for example, the Ethereum people, and this week is kind of a funny time to be talking about Ethereum, but they are actually changing it so that the language used to script their blockchain is going to be using WebAssembly instead, because it's just instructions, and so you can use it for other. Basically, it has this mechanism they call host functions that allows you to call. So, like when you embed a WebAssembly program, it sort of has like, I need these external functions to be defined, and you can define them. So in the Ethereum context, it would be manipulating the blockchain, and in a web context, it would be browser APIs. So that's kind of the mechanism, but they kept the web stuff separate so that you can use WebAssembly for totally non-web applications. It also has sandboxing inherently, so WebAssembly cannot manipulate external memory. It can ask the embedding environment for a chunk of memory, and then it can mess with that, but it can't break out of it. And so the embedding environment will do a bounds check, so it can guarantee that you're not breaking outside of that box. And so it's kind of inherently sandboxed. So a lot of embedded device manufacturers I've heard are like looking at WebAssembly for like, so my TV has a Roku built in, but like, why not have each of those apps be written in WebAssembly and be sandboxed and be much safer that way? So that's one thing that's exciting about it, is it's actually an interesting technology totally separate from the web. But on the web, it's exciting because it means it's the first step towards the web platform being good for applications in general and not just web applications. And what I mean by that is traditionally like people don't think of their browser as being similar to the JVM, but it actually is. It's a virtual machine, and it has an API to interact with stuff. And you, as a web developer, like we focus a lot on HTTP, but that's just the delivery mechanism. Like the actual and applications are using this, browser platform. And the rise of JavaScript over the last 5 or 6 years has sort of shifted. Like we used to be all server side, and now it's slowly moving some stuff client side. But WebAssembly is going to let us write entirely client side real applications that can replace desktop applications instead eventually. And part of that is as the web platform grows. So for example, Web USB is a spec that people are working on that will allow your web browser to talk to USB devices. And so that means I could write a like quote unquote web app in Webassembly that when you download it on your computer, it can fetch images off of your USB stick without needing to talk to the external thing. And so that leads to even more exciting opportunities in the far future, like Chrome OS, but like way more intense, like as in like the browser is literally in the kernel and, you know, like
else.
that, with nothing else at all. There's an amazing talk by Gary Bernhardt from 2013, 2014 called The Birth and Death of JavaScript, where back then, when ASM was new, WebAssembly had not been existed yet, it was just ASM. He gave this sort of talk where he pretended to be living in the year 2035, and he was giving a 40-year history of what happened with JavaScript. And he's like, once you have ASM, like, and you can run real programs, what if you have a compiler, then you can compile programs to that thing. So most people will not write WebAssembly by hand. They will write other programming languages and compile them to WebAssembly. So right now, that's mostly C, C++, and Rust. And the reason it's mostly that is that technically you can have other languages, but there's no garbage collector. You can't access the JavaScript garbage collector yet in WebAssembly. So that means that if I want to run Ruby in WebAssembly, I have to compile the entire Ruby interpreter to WebAssembly, including its GC. And that means I'm downloading 20 megabytes every time I hit a web page, and that's like too much, right?
A little bit extra.
So C, C++, and Rust specifically have an advantage in this space because they don't have this complicated runtime. And so today, those are the only things that really exist. There are other things, and they do, like C# does actually compile to WebAssembly in like kind of an interesting way. But you get this much thicker client, so it's a little harder to deal with. And so eventually WebAssembly is going to be adding garbage collector integration, and that will open it up a little bit to other languages. But still fundamentally, C, C++, and Rust will always have this sort of low resource usage advantage, basically. And so the Rust compiler is written in Rust. And if I can compile Rust to WebAssembly, which works today, we're going to make that better over the next year or so, but like it does work today. If Rust is in Rust and I compile WebAssembly to Rust, I could compile Rust C to WebAssembly and then run Rust C in my web browser. And then I can compile Rust inside my web browser with Rust. And now, like, there was one of my fellow Mozillians, Dan Callahan, did a demo last week where he compiled DOSBox to WebAssembly and then ran Netscape Navigator 1.0 inside of DOSBox, inside of Firefox today.
Where am I again?
Yeah, exactly. And so when we talk about like the web changing, like that's the actual promise of WebAssembly is like someday we could in theory have the browser be for any kind of application, and it's like kind of gimmicky, like who wants to run Netscape Navigator inside your web page?
Well, I do.
Yeah, right. Maybe, some of us want to for like fun technical reasons, but like, you know, a long time ago, like I said, I grew up with Macs, and but we never had that much money, and so my mom wanted to get a new computer but couldn't afford a Mac, and I realized that she only ever really used Firefox. So I built her a Linux computer using Ubuntu and Firefox, and realized that all the work she did was in a web browser, so it didn't matter, and to her it was all the same thing, and so that was totally fine. So when I think about the fact that I pretty much only use my browser, I switched to Windows recently, actually. It's funny being involved in open source for so long. So now I use PowerShell and VS Code. And like, if PowerShell and VS Code and Rust C ran inside my browser, I wouldn't need anything else other than the browser.
Could be anywhere.
And so we could totally have the browser and the web be a platform for any kind of application whatsoever. And that means that web developers are no longer restricted to what we think of traditionally as web applications, but thinking of them as like real applications. And it's important to note too, so like the first thing a lot of people think when they hear this situation is they're like, okay, so now I'm going to get viruses by going to a web page.
You said USB, that's scary.
Yeah, totally. And so the important thing to remember is that, like I said earlier, WebAssembly is sandboxed by default and only has access to these functions that you provide to it, which means sort of two things. One, there will always be bugs in the browser itself. And so, yes, there are some security vulnerabilities, but no more than would already be in JavaScript today. Mm-hmm. Remember that most production implementations of WebAssembly rely on your JavaScript VM. So they already have the same restrictions security-wise that JavaScript does. Yeah. And so it's a matter of us making sure that we design these specs so they don't introduce big holes and, fix bugs when we find the bugs. So that doesn't really change from today. And the second part sort of about it is that no, I guess it's sort of similar. Like these. Oh no, that was what I was going to say. So because WebAssembly module says I expect these external functions, you can actually audit that before you run it and say this program will require access to your USB drive. Do you want to do that? Yes or no? And so I think that as we add more fancy features to the web platform, we'll be able to do these kinds of questions. And it also means that you could do totally an iOS or Android style, okay, yes, you have access to my camera. No, you do not have access to my USB drive. And then that would just return error, and that functionality would, in a good written program, it would just, not do those kinds of things. And so you can know that without executing any of the WebAssembly code ahead of time. And it's designed in such a way that it's not... Anyone who says everything will be perfectly secure will always be wrong. So I'm not going to say that some enterprising hacker is not going to figure it out. Of course. But a lot of care has been put into building a security model around it that does not, violate what we expect on the web. And obviously there's security vulnerabilities on the web, but not the kinds that we have outside of the web breaking into going to a web page.
So what's? I mean, I realize now that I actually have read up a bit of WebAssembly, so I recognized at least the basic parts. But what's the most common misconception or misunderstanding about?
I think what it is? The most common misconception is this is going to kill JavaScript. So
people think, it's a new language replacing it.
Yeah, and a lot of people who hate JavaScript are excited about WebAssembly because they believe it means it will save them from JavaScript. And there's sort of a couple reasons why that's it's not that that's not true, but that's not going to be true for a long time, if ever. Yeah. So because it's about this backwards compatibility, first of all, we can never kill JavaScript because there's a lot of JavaScript code out there, and that code still needs to keep working. Yeah. So you're still going to have that in existence. And secondarily, WebAssembly is very minimal right now, and that's actually why this has been able to work, is that one of the other ways that the previous things failed was they were too big. Mm-hmm. Here's an entire platform put into a thing. WebAssembly basically only gives you integers and floating point numbers and basic manipulations and function calls, and that's it. And so they're adding more over time, but what it means is, for example, you can't manipulate the DOM directly from WebAssembly today. You have to call out into JavaScript from WebAssembly to manipulate the DOM, and that's slow. And eventually they'll add a native DOM API and it'll be fast. But right now, a lot of stuff is still privileged with JavaScript, and a lot of stuff on the web platform will sort of get a JavaScript and WebAssembly implementation in the future. And so it's not until that point that you can even ever do the thing. But the fact is that because the runtime of JavaScript already exists on your computer, it will just be more lightweight to use JavaScript than to use other languages most of the time. And so I believe that will keep JavaScript in, relatively dominant in terms of the scripting language of the web. I think it will always be a good choice and sort of the default choice for those reasons. Yeah, exactly. And it's already on the computer, so it's just that's a really big advantage. And so I think that's the biggest, probably one of the biggest misconceptions. And the security ones are another thing. And people are ad blockers will go away because now you can't ever do ad blocking. And it's well, no, those still make requests to other domains, and those domains will still be blocked. So it's no different. It's funny because it's not different than JavaScript. And then you're well, why do I care? And then you're but it's much different than JavaScript. And so dealing with that back and forth, I think, is where a lot of the misunderstanding about certain thing lies.
You can easily lose someone on the way.
Yeah, exactly. You're either no, it has the same security model as JavaScript, and then they're oh no, or oh, okay, that makes sense. And So I think those are the big things. But I think over the next 3-ish years, it's going to be a massive, massive change. And I think even the people that are enthusiastic about it don't appreciate how significant it's going to change the web as a platform. Like, I think it's going to be the biggest thing since JavaScript was added to the web, period. So I'm incredibly excited about it. And the fact that Rust works really well with it and will work even better in the future is just like a great way to tie it into my existing work too. So that's also a plus.
It just fits in nicely.
Yeah, exactly.
Yeah, it's going to be super exciting to keep following it.
Yeah.
Steve, thank you so much for taking the time. This is super interesting.
It was tons of fun. Thanks for having me.
Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.